Hello friends, welcome back to my channel. Now in today's video, we're going to look at how to use KServe to deploy a model. And by model, I mean a machine learning model. So first, we will look at how to set up a Kubernetes cluster using Minikube. We will set up a Kubeflow environment. And then we will use Kubeflow to run a pipeline script that would push or register trained machine learning model to an AWS S3 bucket. And then from there, we will start creating our KServe environment. And for that, we will create a Knative application. We install Istio. We install the KServe itself, search manager, and stuff like that. Now, with our trained machine learning model saved to the S3 bucket, we are going to use an InferenceService to deploy the model to KServe. Now, we want to have an interaction with the model. So I'm going to expose the machine learning model via an external tunnel, which will act like a load balancer. And then we will use a call command to draw inferences from that model. So please stick around for the entire video, and I hope you learned something new in this video. Please like, comment, and subscribe to my channel for more videos like this. And now let's get into it. Now for the overview of our code, I pretty much have the same code from the previous video. By the way, if you've not seen the previous video I did on MLOps, this is the video number 3 on Let's MLOps series, where I show how to create a Kubeflow pipeline. Now, in this current video, I basically have the same code apart from the fact that I want to register the model that I train to Amazon S3 bucket. So the only changes I made to the code are at the training model stage or that function, where in a Docker image that we are using as our base image Python 3.9, I'm going to install these packages in there. Now for the first 3 are packages we've used in the past already. Joblib for the model, sklearn is our library, and this is another library we're using. And then we are going to install S3fs, that's for S3 file system, and Boto3. Boto3 is used for interacting with AWS via command line interface or CLI, right? So we will store that in the Docker container, which is our base Docker container. And then from there, we will import them here. See the Boto3 and the others that we will need. Now, we are also going to import datetime because sometimes the time in your local system and the time on AWS account has to synchronize before you can do certain interactions, right? So we will use that as well. Then the code remains the same. Now here is where we initiate the Boto3 client, which is gonna create the configuration or the link between our AWS account and the local system. And of course, for that, you will need an AWS user. And for AWS user, we have to attach some key ID and a secret key. So we will look at how to do that later. Now, once that is established and the timestamp on our system is the same as that or synchronized with that of AWS, then we can create a path where we can push our ML model to. Right. So you upload a file using this function here. And then the rest is just some metadata, the model URI. Now, when you push it to AWS S3 bucket, you'll be able to rectify this, what this is. So that's really the only new thing that I'm doing in this section. So the rest of the code remains the same. Now, when I go to the bottom and I'm defining the pipeline, I need to make sure that the pipeline that I'm defining has access to the secret key and the access key ID. Now, this will make sure that when we build our pipeline, we are able to send it to the correct AWS account and to the correct S3 bucket. Now you can also provide these 4 variables in the Kubeflow pipeline UI. Of course, it's in the training stage that we are going to push the model, so we need to give the access to the key and secret key IDs as well, and everything remains the same. I have the code on a GitHub account, so I'll leave the link in the description below. By the way, if you want to go through the entire project, I have a README file which is very detailed from start to the end. So just list all the requirements. You need Docker installed. If you're on Mac or Windows, you need Docker Desktop. On Linux, you need Docker Engine, kubectl, Minikube. You can set up a Python virtual environment, but that's optional. You need to install KFP. You need an IAM user on AWS with S3 privileges. You need an S3 bucket, and then you need a custom domain name. That's pretty much the overview. Let's get into the actual project. Now, I have all the codes in the GitHub repository that I'm gonna follow. This is a pipeline script, the same thing I showed in the previous section. And I've prepared a README file that you can easily follow with the requirements and how to install them and everything. At this stage, I'm gonna look at how to set up my EC2 instance. Now, Kubeflow and KServe are computationally intensive. They need at least 4 CPUs and then at least 8 gigabytes of RAM and some reasonable storage. But my local computer, my MacBook, only has 4 CPUs. I have enough memory, 16 gig, but the CPUs I don't think are enough, especially running Kubeflow and KServe at the same time, trying to have the Mac OS running and then using OBS to record the video at the same time kind of breaks it down. So that's why I'm doing this on EC2 instance. But if you have enough resources, you can easily run it on your local machine. So I'm gonna create a T3 2x large that comes with 8 CPUs, 32 gig of RAM, and I'll add about 80 gig storage. Now this is roughly 33 cents per hour. So let's go to our EC2 instance page. Click on launch instance. I'll call this KServe. I'm gonna use Ubuntu, and that is Ubuntu 24. Now for the instance type, it's gonna be T. Alright, this is T3 2x. Create a new key pair. Give it the same name, KServe. And that's downloaded to the downloads folder and it's selected here. And for the storage, I'll use roughly 80 gig. Okay, launch instance. All right, back to our instances. That's our instance running. You select it, you should see all the information about it. This is our IP address. Key pair is downloaded to the downloads directory. So on my local terminal, I'm using Visual Studio Code as my terminal. Make it a little bigger because I have multiple tabs open here, but I'll first cd into my downloads directory. Right, this is my downloads directory. So SSH -I. By the way, the command is right here. You can follow it. But first, I need to actually make it executable. So I'll run the ch mode first. Control C. And the key pair is kserve.pem. Then I'll run SSH-I, the key pair, Ubuntu, and then the public IP. So SSH-I, key pair, Ubuntu, public IP. The public IP is selected. Press enter. Yes. And we are in the server. So I can clear the screen now. So following our pipeline code here, first let's update the system. The update is done. I'm gonna clear the screen. Next, need to install Docker. You can run all the commands or run them one by one, either way is still fine. So this will install Docker, and then this will add Docker to the Docker group. Add this. Docker group already exists, and let's add this user to the Docker group. Usually when you install Docker, you have to restart your server, but if you run this new group Docker, it restarts it automatically, so without you trying to restart the whole server. All right, so Docker is done installing. If I do Docker version, that's our Docker version right there. Playing the screen now. Let's install Kubeflow. Now, since my system is Ubuntu, I can use the Snap app packaging software to install Kubeflow. Install this. That's done. It's pretty quick. Now, to check the Kubeflow version, run this command here. That's Kubeflow installed right here. Next, first let's check if Python 3 is installed. Normally it comes with it. Okay, so it's already installed. What about pip? Pip it's not installed, so I need to install it. So I'll run this third command here to install pip. That's installed pip. Next, I want the entire project that I want to do to be in a virtual environment. So I will create a virtual environment running this command. Right, that's done. Now I will redirect Python 3 to this virtual environment I just created by running this command. Okay. That's good. Now when I check the Python version and the pip version in the virtual environment, it should give me the same results. Okay, that's the Python version, and this should give you the pip version. All right, that's the pip version 24.0. Right, now if I need to use the virtual environment, which I actually need to, then I have to clear the screen here and run the source, and then this command will activate the virtual environment. So you see currently it's just Ubuntu. You see, if I run this command, you should see VNV next to it. So which means everything I'm gonna run is gonna be in this Python virtual environment. That's good. Now you need to install Minikube and then the Kubeflow SDK and stuff like that. But before we do that, there was something I skipped earlier here. Now there are certain ports we need to open on this server for easy communication with our model, both Kubeflow and KServe. So we need to go to our EC2 instance, go to security, then we are going to make some changes to the inbound rules. This is the inbound rules edit. But port 22 is already here, so we will add the rest. Have port 80, and this port 80 is for HTTP, Apache. Then we have port 443. This is for HTTPS. There is port 8443. That is for the Kubernetes API. 8443, the Kubernetes API. We have port 8080. I'm gonna use that for my Kubeflow UI. Kubernetes node ports, I'm gonna allow this range. This is for node port services in Kubernetes. We have port 5000, 8081, and 9000. Now, if there are some ports you may not need, just leave them out. Okay. 5,000, 8081, 9,000. And these are ports for KServe. To make it from anywhere. Of course, you can make it from my IP. It's pretty much the same. So these are for KServe. Some of them are for KServe inferencing. Some are for KServe model serving. Okay. Right. Now all of these are factored in this range of ports, so that's fine. And then save the rules. Now I can go back to my EC2 instance. You see the updated security rules. Everything looks good now. All right, let's move on from where we stopped. I believe I stopped right here somewhere. I'm gonna install the Minikube. We run these commands. Should install Minikube. And run that. If I check Minikube version, that's my Minikube version installed successfully. Now it's time to start our Minikube cluster. Now I'm gonna create it with 4 CPUs, 10 gigabytes of RAM, and I'm using the Docker as my driver for my Minikube. So copy this, press enter. This should take a few minutes. Okay, so it's done. If I do Minikube status, Minikube is running. Or if I do Docker PS, since it's using a Docker driver, you see the Kickbase Minikube image or container running right now. I'm gonna clear the screen. Good. And of course, if you get nodes, you have only one node, then you can get the cluster info for the Minikube API. This is the core DNS or the control plane. That is the core DNS. You see, this is the port 8443 that I added. Okay. Now, before I install the Kubeflow SDK, I'm gonna go to AWS. And then I'll go to IAM. Open this in a new tab. This. Okay. Now I've restructured the code that I used in the previous project such that now I want to push it to an S3 bucket. So after running the pipeline, I want to push the final model to Amazon S3 bucket. And you can see I've configured it in the training step. This is the train model step. And because of that, I need to create an AWS user. So in IAM, go to users. And these are some users that I have. I'll create a new user and I'll call this user, let's call it KServe. I will not give it access to management console, which is the graphical user interface for AWS. I just need it for the terminal. And then go to attach policies. Because I want to push to S3, I'll give it S3 privileges. I'll just make it full. That's fine. So S3 full access. Now you can also use admin access, but in AWS, you always want to give the minimum permissions or policies possible, right? I'll just use S3 access. Next, create user. Right. So my user has been created. This is my user, KServe. You can click on it. I need this user to help me with my uploading of the model to S3 bucket. So I need to give it some keys. Because when I run this pipeline on Kubeflow, it will ask for, I believe, 3 things. It will ask for access key, secret key, the bucket name, and then the bucket key. The bucket key is basically folders inside the S3 bucket, right? So I'll create some access keys that I'll use for that. I'll give this CLI. I understand. Next, for this KServe access keys, create access keys. It's created it. This is the access key and this is the secret key. All right, I will just download the CSV file. It's downloaded right there. I've saved it safely on my local machine. Done. Now we can go back to our EC2 instance and follow the README. We got to this point. So before I go on this terminal, let's see if AWS CLI is installed. Version. Okay, it's not installed. So I'm gonna install AWS CLI Ubuntu. Okay, this is an Amazon documentation, so I can use that. Linux. I run this curl command to download it. Okay, so there it is. Download it. By the way, the path you see here is the path of the virtual environment, and this is the repo for the Snap app packaging software. Right. And we have to unzip. Okay, I don't have unzip installed already, so I will install that first. So it's installed. I can unzip it now. So it's done unzipping. Let's clear the screen. Now if I run sudo.aws/install, done. Okay, so if I do aws -- version, that's installed successfully. Okay, so let's configure our IAM user that we just created. So run AWS configure. The access key you get from the CSV file that you downloaded from our user. Copy it, paste it here, press enter. Secret key, and copy and paste it here. Region, I'm using US East 1. Output, I'll leave it at default. Okay, so our user is currently configured on our terminal. All right, so I'm gonna clear the screen. Back on our README. Okay, we need to create an S3 bucket. So let's go to S3. So this is our Amazon S3. And again, I need this particular bucket. You can change the name, of course, but I want it to have the exact same here. So on my S3, I'll create a new bucket, the general purpose bucket, give it the exact same name there. Leave it as recommended, block public access. We don't really need version right now. Okay, keep everything as default. Of course, if you want to make any changes, that's fine. Create this bucket. And there it is. This is the Kubeflow bucket iQuant 00. Now, if you go in, see that it's currently empty. But when you run our pipeline, it's going to create a directory called models, another directory called iris, and then the model that we will create will be inside this iris directory. So we pretty much have everything set up at this point, except for the Kubeflow stuff. All right, now for this stage, we are going to install our Kubeflow. And again, just follow the README. Now we need to install KFP, which is the SDK for Kubeflow pipelines. First, I will check if it's installed or not. It's clearly not there. You get no output. So I'll install it. By the way, I'm installing it in the virtual environment. As you can see, it's already activated. Install KFP. It's done. Let's clear the screen here. So when I run which KFP, you should get this. So it's installed in this path. Next is to install the Kubeflow. First, export version. Of course, you can run all of this together. Run them one by one. I prefer to run them all together. So I'll copy this. Paste them all here. Press enter. Now this may take roughly from 15 to 30 minutes, depending on the system that you have. If you have a very powerful system, it should be done in 15 minutes. I'll pause the video and then I'll come back once it's ready. All right, so I've paused it for a while. Let's clear the screen now. Okay, from our README, you can do kubectl get all inside the Kubeflow namespace. That should give us our resources. Now you can see everything is ready now. We have pods here, services, we have the deployments, and we have some replica sets all ready. So the next thing is to access the Kubeflow UI on our browser. Now, if you're doing this project on your local machine, then just run this command and then go to your browser and run this localhost 8080, port 8080, and that should give you the Kubeflow UI. Since I'm using EC2 instance, I'm going to use the option 2, which is to run this command here. And then I'll use SSH tunnel to run this before I can access it on my browser. Okay, so first I'll run this. Let me clear the screen. Run this command here. Right. Now I need to open another terminal. So I'll use this terminal. Again, cd into the downloads directory. Instead of logging in, I'll run ssh-i, the key pair. Key pair is KServe -l. I'm using port 8080. Okay. Localhost. The user is Ubuntu. And the public IP address right here. Paste it there. Press enter. This will keep loading. But if you go to the other port forwarding command here, whenever we open a browser to check the Kubeflow UI using this command here, we'll be reading on that page. So press enter. That's the Kubeflow UI. Now if you go to the terminal, you see that it's reading it here. You can see the connection. But this will look like it's not running, but it's actually running in the background. It's tunneling the connection to the port forward. I need another connection to my server. So I'll ssh-i KServe public IP. Okay, so this is inside the server. Now, because we're using the virtual environment, I want to activate it again. So I will run this command here to reactivate the virtual environment. You can see that you can see the VNV right there. So activate it, and now you see the virtual environment. And this is our Kubeflow UI. Currently, these are some tutorials on there, but we want to do our own. So I'll create this file called pipeline.py, or I can just clone this repository, because this pipeline.py is the same as this file right here. Let me just clone this repo. So go to code, copy this clone link. So git clone, paste this here. All right, so it's cloned it inside this Kubeflow KServe directory. So I'll cd into Kubeflow KServe. That's our pipeline.py. If I do vi pipeline.py, this is our code. Okay, everything looks good. I'll exit. Okay. Let's go to the README again to follow it. All right, so first we need to build the pipeline, which we so currently the pipeline is a Python file. You will build it using Python, and that will generate a YAML file, okay, or a YAML script. Now that YAML script, you can give it any name. So in the pipeline code, scroll all the way down. This is the name that we are giving to our YAML script. So by running or building the pipeline right here, the YAML file is generated, and that will create our pipeline. Okay, so by the way, we are running on virtual environment, so you need to add the full path to the Python on the virtual environment. Run this. So I'm currently inside the Kubeflow KServe directory, so let me go back one level right here. So I need to run a path to the pipeline.py, but it's inside the Kubeflow KServe directory, and the pipeline.py is inside it. So I'll run this instead. Now, if I do ls, it actually stored it inside the current directory. Okay, so that's our pipeline.yaml. Next is to run our actual pipeline using this command. Now, this time the YAML is inside our current directory, so no need to direct it. And I'm giving it the name Iris project. So this is what's going to appear on the Kubeflow UI when you run this command. Press enter. That should run it. So let's go to Kubeflow UI. Refresh this page. And there it is. That is Iris project. Click on this, and this is the version that we just created. And that's our pipeline. Now we are going to create a run of this pipeline. So create a run. I'll keep this as default. Experiments. Now, these are the variables that I mentioned earlier that the pipeline will demand for. So the access key that you created for your user, this will help with the pushing the model to the AWS S3 bucket. Secret key. Okay. This is the bucket name. This is a string or the folder levels inside the bucket. You can modify this actually here as well, but I will just leave it as it is. Start run. Now this will take a few minutes, so I'll pause the video and come back once it's ready. Okay, so the data is loaded. The pre-processing of the data has started, and the pre-processing of the data is completed. You have your train and test data ready. And now the training of the model has started. Training is done, and now we are evaluating the model. All right, the model evaluation is also successful, so the whole pipeline was a success. So let's go to the S3 bucket and investigate if it actually worked. So this is our bucket name. Click on it. Refresh this. So you see the directory models. You go in, you see the Iris directory as well. There it is. And then inside it, you should see the model. Now model is .joblib extension. So this is the model. All right. So that's how you would push the model to your S3 bucket. Again, I have all the instructions here. So just follow the README and you should be able to do that. Okay, Now at this stage, we are going to look at how to deploy our KServe and then deploy the model onto it using InferenceService. So there are some things we need to do. We already have our trained model in our S3 bucket. Let's first install Helm. So I will clear this screen. There's this link to install Helm. All right, Helm is installed. Next, you need to install Istio, Search Manager, Knative, and then KServe. And you can install that using this single link here. So copy this, paste this, and run it. This may take a few minutes. All right, so it's installed everything and finally installed KServe. Right. This took a couple of minutes. Let's clear the screen here. And now we're gonna verify whether the installation was successful by running these commands, kubectl commands here, and their corresponding namespaces. That's for the KServe, it's running. This is for the Istio, that's also running. The next one is for Knative serving, also running. Good. Next, I'm gonna enable ingress for my Minikube cluster. I'll run this command. That should enable ingress for Minikube. We should have done this earlier, but it's still fine. All right, so ingress is enabled now. Good. Now we can check the ingress controller. There it is. It's currently running right there. Now with that, I'm going to expose Minikube with an external IP address similar to a load balancer, but not really a load balancer. I'll do that by running Minikube tunnel. Now this creates a tunnel so that when by the way, I have all these tabs open. Okay, so I need to create a new one. Go to user, downloads, SSH, KServe, Ubuntu, public IP. Right, so this is in again. Now, in the previous one, we ran the Minikube tunnel command, right? Now with that loading on the other side, when I run Minikube IP, you'll see that this is our Minikube IP address. If you check our services for the ingress gateway, at this point you should see an external IP address assigned to our Minikube ingress gateway as a load balancer. Okay, so we can use this external IP as a load balancer. With that, I'm going to set some environment variables. One is ingress host, and then the other is ingress port. All this command is going to do is it will parse this output here. So it's first looking for the status, load balancer, ingress, and then we'll pick the IP address. And then we'll do the same for the, so it's picking up HTTP2, which is a port 80. Pick that up. So, and then we save it as an environment variable ingress host and ingress port. So I'll copy these two commands and run them. Just run them separately. First one. Second one. Okay. That's done. Next, I'm going to create some namespace for isolation for inference, right? And our namespace is called KServe test. Create this namespace. That's good. And then we will create an inference service. You can actually create an inference service or create a YAML file and then copy it from this point up to that point in there. And then you can do kubectl apply the file in the namespace KServe test. All this is doing is from the start of EOF, this creates a beginning of a file, and when it sits EOF, that is the end of a file. Okay, so this is like a shortcut. Now you see that here you see storage URI. This is where you would go to the S3 bucket. This is our model. If you select it, you can easily copy its URI using this copy S3 URI right there. Okay, I will paste it on the. This is how it looks, S3 URI. But for some reason, I'm having issues deploying this particular model. Perhaps because I didn't really pay much attention to the actual coding of the model itself, data science part of things. It's mainly about the ops side. That's why I guess I'm having that issue. So instead of using that to deploy a model, I have an open source model here, which is also a logistic regression model. And this should work too. So I'll just copy the whole of this here. Paste it, press enter, and you see that it has created an inference service. With that, you can check our inference service. By the way, this is the name, sklearn iris. That's the name right there. And this is a resource of type of kind inference service, which is right there. And it's created inside this namespace KServe test, which is right here. So we can use this to check our resource. Paste. And you see it's unknown for now, but it takes a while for it to come up. So since it's not ready, let's check our ingress gateway again one more time. It's still running. Our load balance is fine. Give it some time, it should be ready. Okay, so you see that now it's ready. And this is the URI or URL for our model. So since it's ready now, we can create a JSON file and then use it for prediction. Okay. So you can create a iris input.json file and fill it with this content, or as a shortcut, similar to how we created the inference service here, instead of creating a file, we can use this and it will automatically create the file with this content. Right. Right. Let me clear the screen for now. Need some more space. I'll run this again. And then I'll run the cat command to create the .json file. If I do ls, you should see this is a JSON file, which is right here that I just created. Right. With that created, we use that data to interact with our model. And for that, we need to set a host name, environment variable, and that is from when we run kubectl get inference service, the model name in the namespace. This will go to the status URL and pick that up as our service host name. So this is just parsing or scraping this particular link, which is the URL, as our host name. Okay. We'll save that as our host name. So I'll copy this first one, paste it here, press enter. Next is to run a curl command that would interact with our model using the JSON file that we just created. So this, we use curl to interact with the URL of our model, which is that, and that is saved as our host name. And we are using JSON file to interact with our model, and that JSON file is iris inputs.json file we just created right here. Okay. And to interact with that, we need our ingress host. That's one of the environment variables we saved earlier. Ingress port, that was another one. This is our model. And then we are trying to predict. Okay. So with this, press enter, and you see prediction 1-1, and that is your correct prediction from our model. Now with that, you've successfully deployed your model, interacted with the model and everything. Okay. But you can see something here. In the README file, if you go up, you see here you need a custom domain name. Now in the example that I deployed, their domain name is example.com. So suppose you are doing it in a company, or you have your own domain name that you can use, that should replace this example.com. So for instance, well, this is successful, so we are pretty much done. So if you have a domain name and you want to use that instead of the example.com that we have for that example that I ran here, what you would do is, so let me first clear the screen here, and you run the command kubectl edit config map or CM. By the way, let's get config map in the Knative serving namespace. Okay, and this is a config -domain. So I'll use that. I'll edit kubectl edit config map, and this is the config map I'm trying to edit, and it's inside the Knative serving namespace. Press enter, and this is the config map configuration for the example that we use for the example.com, and you see it right there. This is it, example.com. There's another one for example.org, right? So if you have your own namespace, what you would do, actually I didn't copy. I need something that I didn't copy. I will just quit this. I need to run the command that provides the external IP address. That's the ingress gateway. This is external IP, so copy this external IP. Or if you have your domain name service, you can copy that as well. And then you can edit the config map here. Just scroll down, and under the data, you can add any domain name or records that you may have. Okay, so I'll use my external IP address, and then I'll do .xip.io : and then put the slash sign there like that. Now what this does is it creates a magic DNS such that if you want to serve a simple model in your local environment or something, you can easily use that as your DNS. With that, I will save this file, and you see that it's edited. If it's edited, then let's check our model. Yeah, the ISVC is the same as the InferenceService. Okay, that's the short form of it. Press enter, and now you see that the .example.com is changed to this as a domain name, and you can still interact with it using the command that we ran earlier. First, run the host name, because this host name picks up the URL. Now the URL has changed, so we need to rerun this again, and then you can run the curl command. You can see you get the same prediction from it. So that's how you would build a machine learning model with Kubeflow, and then use KServe to deploy it into production. Now, if you want to do a cleanup, you need to first delete our inference service we created. Clear the screen here. Delete that. Next, you need to stop the Minikube. Minikube is stopped. You need to delete Minikube and all its corresponding sources. That's done. And then, so the connections are already being lost. So Control C, you can use it to exit all of them. Control C. All of this has also exited. All right, so everything has exited successfully. And that's pretty much it. Our Kubeflow should be down by now. So it's gone. All right. Thank you for joining me again on this project. Please like, comment, subscribe to my channel for more videos like this. And I'll see you on the next one.